2. The integral from 0 to 5 of 3x squared dx. Alright, so think about 3x squared as being a derivative. What would the original function be?
X.
Well done. Spot on. Good. So it'll be x cubed from 0 to 5. So that's going to be 5 cubed. Oops. Oh, jeez. Minus 0 cubed. Therefore, that is 125. And again, what have we actually done there? Well, 3x cubed looks like that. Oops. Right. And it's going to be squashed in. You know, if x cubed, 3x squared is what I meant to say, sorry. If x squared is like that, 3x squared is going to be like that. It's just squashed in a bit, right? And it's saying from 0 through to 5, what is that area there? It is 125 square metres. It won't always be exact, it won't always be an integer. In fact, I'm surprised that it is, but there it is. That's how you work it out. Are we cool?
Yep.
We good? Okay, let's have a look at the exercise. So, wait a minute, I'll rub this off. 1 minute. So exercise 3.3.
Yep.
Yeah. 3.3. So 1. So we're on page 101. We all there? Right. So integral from 0 to 2 of 4x dx. Now think about what function will give me a derivative of 4x. Well, it's going to be 2x squared. From 0 to 2, which is going to be 2 times 2 squared minus 2 times 0 squared. So the answer is 8. You don't really have to put the unit squared. The answer is 8. Now, after a while, you get very used to being able to find derivatives, integrals. Pardon me. I shouldn't say that. I should say you should get used to finding primitive functions. That's what I should say. Let's do question 3, just because. Question 3 is the integral from 0 to 5 of 3x squared dx. Now I've done that in the example. Let's do something else. Sorry. Let's just wrap up the one I've used as an example.
Okay.
Yeah. Yeah, let's do 2. Um, 1, 2, 3. Oh dear, oh dear, that's the one I've used in the example as well. For God's sake. Dear, oh dear, sorry. Let's do question 5. Let's get right away from this. Question 5. -1 to 1 of 6y plus 5 dy. Now, do you notice it really doesn't matter whether there's an x or a y in there because it's saying with respect to y. This is saying the integral with respect to x. This is saying the integral with respect to y. It makes no difference to the working out. You know? So, if I was to work out the primitive function of that, can you see that that's going to be 3y squared plus 5y between -1 and 1. So that's going to be 3 times 1 squared plus 5 times 1 minus 3 times -1 squared plus 5 times -1. Which is what? 3 plus 5 is 8 minus 3 minus 5 is -2, so it's -2, therefore it's 10. I'll do one more and then you take another photo. So let's say 7. So we've got the integral from 1 to 2 of x squared plus 1 dx. So, the primitive function of x squared, you see that it's going to be x cubed, but I have to get rid of the 3. Therefore, I'm going to divide it by 3. You see, if I take the derivative of that, I multiply it by 3 and take 1 away. So if I take the derivative of x cubed, I'm going to get 3x squared. I don't want 3x squared, I want 1x squared. Therefore, I have to divide it by 3.
Okay.
Yeah? Plus x from 1 to 2. So that's going to be 2 cubed over 3 plus 2 minus 1 cubed over 3 plus 1. Which is going to be, what, 8 over 3, okay, 8 over 3, this is going to be 6 over 3, minus 1 over plus 3 all over 3, so that's 14 over 3 minus 4 over 3, so the answer is 10 over 3.
Why is it 1 plus 3 over 3?
Okay, because I just converted that to 3 over 3, so that I can put them
yeah.
all over the same denominator.
Yeah.
Same deal over here, I made the 2 6 over 3, so I can put them all over the same denominator. It just makes it easier. Alright, take a photo of that.